I have just one request. If anyone has any good resource about learning Kubernetes, if they don't mind, can they pass it around?
Sure. Just any general thing on Kubernetes?
Yeah, I have gone through docs, but it can be quite intimidating for the beginners like me. So means it would be better if there is any sort of link and all where I can get the basic idea. Then I can ramp up.
Sure.
I did at first when I started to sort of, I think I did. Was it the? I read a book, um, Deep Dive Kubernetes. I think it was actually by Kelly um, Hightower, Kelsey Hightower. Really good, and I think there's a good tutorial on Pluralsight. I don't know if you know this the site, and from there on, you have enough of a basic to sort of create a whole bunch of things and learning from there. That was my experience.
Do you have a link?
Yes, I'll post it in the chat.
Okay, sure. Thank you.
Ankur, is your new job going to do Kubernetes related things?
Sort of during the interview, I mean, JD has those things, but I'm not sure at what point I will be starting. So I'm just doing my job from my side, getting a ramp up and everything so that I can pick up pretty quickly if required.
Awesome. Okay, I think we were waiting for Mani to, he was going to present today. I'm waiting to hear on Slack. I think he's writing right now. Let me just give him the URL real quick. All right. All right, I'm gonna just get started with my two little announcements. I think he's on his way now, so hopefully when I'm done, he'll be here. So first thing, I haven't posted the videos from last week or this week. Obviously not this week because it's not done recording. But after this, I'll post both at the same time. So that's number one. Number two is we have a blog on Medium that's completely empty right now. The first post I'm going to put will be just that the videos are up. And we also, I think, we have a Twitter account now too. So if people want to write on the blog or do some sort of I've been calling it content promotion on the Twitter account. But basically what that means is if you are doing stuff on the Twitter account, you would be, tweeting out when the next study group is going to happen, maybe tweet out if people have blog posts that they wrote on their own, which we did for Encore's blog post on channels, just general stuff like that. So absolutely anyone is welcome to write posts. Anyone is also welcome to be part of the Twitter. Basically just DM me or at me on the Go Study Group channel. And then my last thing, I put this on the agenda as well. I am going to ask us to try out a GitHub repository for next week's agenda. So that would be, instead of putting your agenda items onto the October 18th Go Study Group section on the Google Doc, it would be going into the repo and adding an issue for the agenda piece that you would like to see. And I want to try this out because I'm basically stealing what GoStudy Group India does with their with their GitHub repository, and seeing if it will work better for us instead of the Google Doc that we use now. So we'll do it as a community thing. If we try it and we don't like it, then we'll do what we're doing now. If we like it, then we'll go over to that. So that's it from me. And I saw Money was here and then he dropped out. I think maybe he had some network problems. Let me see. Okay. He said he's going to come back in a minute. So in the meantime, I will tell you guys about a project I'm working on that's related to the agenda. So I'm going to put in the chat this repository called Agenda API for the GoStudy group. So what my goal is to allow people to put in agenda items somewhere, somewhere familiar, so that like it doesn't have to be a brand new app or workflow or something like that. And then to have this API fetch the items for the coming week and put them onto the GoStudy group homepage. So for people who don't know what that is, I'm typing it in right now. So it would be like, let's say we used the GitHub repository. It would be, go add issues for whatever agenda things you want to hear or talk about. And then the Agenda API would grab those items for the coming week and then format them and stick them into the study group homepage at gophersource.com. So it's a little project I've been working on. I've been screencasting everything I do for it. And if it's appropriate, I'll do some of them in here. We can do some live coding. So I haven't really gotten started in earnest with that so much yet, because we have to figure out where our agenda is going to live. But I will get started on that more earnestly soon. All right. Mani, are you ready to do your demos?
Yeah.
Okay, cool. Take it away.
So we are going to start a bit with theoretically. So first of all, why we need messaging? The reason messaging was required because a lot of applications were communicating in a manner which was not very scalable. Whether it was, can you guys hear me?
Yeah.
Okay. Yeah. So earlier there were monoliths, and then when we jumped to microservices, we used to communicate through different protocols and based on TCP or some other, so which required asynchronous communication. But in microservices, what we do is we try to decouple things. So if there are two services A and B, so what we try to do is we try to minimize the dependency of service A on service B. So how we do that is there are actually multiple ways, but the most common one of them is messaging. So how we communicate between two services is through RPCs or through messaging. And the benefits of RPCs, remote procedure calls, is they are relatively quite scalable, and also provide remove the necessity of any third party like broker and so we achieve very high performance in that case. And when we talk about messaging, what we do is we introduce a third party, which is a broker. And what we do is we send whatever the data we have to share with the other service, we send it to the broker, and then the broker handles how he should share it with the other service. So what we achieve here is the first thing we achieve here is there is separation of concerns. So microservice A does not have to know where microservice B is. So which is a very important thing, because in remote procedure calls and all, we need to know where the other microservice is. So but in messaging, what we do is we connect to a single point of communication, which is our broker, and then we pass message from service A to the broker, and the service B, which has to consume the message, receives the message from the broker, and then does whatever it has to. So what we achieve is we do not have to know where microservice A is currently being hosted, and also we do not have to know where microservice B is currently being hosted. The remote procedure calls basically suffers with this issue. Whenever we use RPCs in our project, we what we have to do is we have to register all the services, which we also have to do in while using messaging and all. But we have to register, and every microservice has to know the other microservice which it is trying to communicate with. So this is a major drawback, as it is not always possible to know what other microservices are running and where are they running. There is another thing that we have to take into consideration is the other microservice which I am trying to contact with right now may not be available right now. It might be down or due to some other reason. I might not be able to communicate with it and get my work done. So what happens in this case is, in case of messaging, the message queue is maintained, and what we do is we pass the message from through the broker. Through the broker, and there is internally a broker is divided into multiple parts. One of them is an exchange, the architecture in a manner of architectural saying. One of the part is the exchange, which receives the message from the sender, and the other part is the queues. So the consumer contacts with the queues. Consumer has no direct relation with the exchange. So what our exchange does is it sends, it basically routes the message to the appropriate user, the appropriate queue. So that's all about the architecture and all. So another thing is messaging. Using messaging, we can implement very complex routing mechanisms. Suppose if for example, just take the case of RabbitMQ. In RabbitMQ, basically it is the best messaging broker for handling complex routing situations. And how it does that is it can handle different scenarios. For example, you can either use the publish and subscribe handling of the messages. Then there are topic wise, which is basically publish and subscribe. Then there is header message passing. You can mention the topic in the header, and then we can listen to that. And then there is obviously the fan out exchange, which basically fan outs to all the queues and with whatever it is listening. So that is.
So Mani, can you kind of go into more detail about publish and subscribe?
Yeah, sure. I was going to do that in. Okay, yeah. Let's just do it right now.
Oh, if you're gonna do it later, that's cool. I don't mind it. Okay. Sorry.
So let me share my. I think I should do it right now. Yeah, it would be better if I do it right now, because after that we are going to jump to code. So how? So there are multiple. What do you say that? I don't know the word. So multiple. Okay. Okay, let's. So then there is a producer of the message. There is a producer and a consumer. These are the two main basically you can say people or communicators. So what a communicator does, it either sends the message or receives it, the producer and the consumer. So what producer does, it passes a message to its exchange. Now the exchange in RabbitMQ are of four types: direct exchange, which sends a message to a queue direct, just in a direct manner of sending routing. Then there is a fan out exchange, which basically sends this message to all of the queues that are currently listening over this channel. And then there is header exchange, as I already said, which what header exchange does is the body of the okay. So in RabbitMQ, the message is a amqp.publishing. It is a type. It is called publishing. So RabbitMQ is based on AMQP protocol, which is again based on the TCP protocol. So it guarantees the delivery of your message. So what happens when you publish, when you send the message to exchange, what it does is it maintains the order of messages, and then it checks the what kind of exchange it is, and according to that exchange and the whatever the queues are listening to, what the queues are listening to, the topics and all, it routes the message. For example, I haven't a slide prepared, but yeah, let's just take an example. There is a exchange A, and then it is a let's say it is a fan out exchange, and then there are three queues listening to this exchange. Then what we do here is, if I publish message from service A to anything over this exchange, I publish message over this exchange, then what will happen is this exchange will see what kind of exchange it is. If it is a fan out exchange, it will send the messages to A, B, and C queue. So all the queues receive this message, and then again whatever the services that were listening to this get the message. If it was a header exchange, if you look into the message and then check into the header field of that message. Every publishing has a header field in which we send the header. It is not mandatory, but we can send the header. And then again, if it is direct, then we directly send it to the related queue. And then if it is topic-wise listening, then we can send it to the all the topics that I'm listening. The queue is listening to. Yeah. And yeah, so that's all about the internals. Yeah. Let me share my screen. Okay. Can you see it?
Yep.
Okay. So, as I said, there are two main entities in this: the sender and the receiver, or the producer and the consumer. So what we do in this, what the sender does is, the usual dial, it gets a connection, dials. This is the default port that RabbitMQ listens on. Yeah, one thing I forgot to mention. Sorry, this wasn't very well prepared. RabbitMQ can can listen on various protocols. It supports various protocols. You can listen on either AMQP, which is the most general, you can say, most general protocol used in industry. But you can also use MQTT. MQTT is also another protocol which is used in messaging. And it is the benefit of MQTT is it can send data over low latency networks, basically the low bandwidth networks. So that is the one main advantage of RabbitMQ. You can use multiple protocols. Also, there is a support for RPCs in RabbitMQ as well, though I haven't been into that. Yeah. So you get a connection, and then you create a channel over the connection. So the channel is basically the variable con here is the actual connection. It is the physical connection that is being established between your system, the sender, and the RabbitMQ server. Now, this channel, it is also a connection, but it is a virtual connection over that connection, over this connection. So what happens here is you are creating a virtual connection over over the physical connection you have to that the server. So in this case, what the advantages are that we can create multiple virtual connections over a single physical connection, so a single real connection. So now we declare an exchange. So so the declare exchange method has multiple arguments here. So an exchange, the first is you can declare the name of that exchange and what kind of exchange that is. It's the second argument. So as I said, the kind can be the direct exchange, then fan out exchange. I have used a fan out exchange here, and then it can be header or topic list. And then
Hey, Mani, I have a question again. Sorry.
yeah, sure.
Can you remind me what direct exchange is for?
Yeah, so it is basically you can connect, you can send the message directly to a queue that you have mentioned in here. In direct exchange, it just directly sends it over. It is a least complicated way of connecting an exchange to a queue.
Okay. Could I use it for like our remote procedure call if I didn't want to just do direct RPC?
So what you are asking is, can you use RPC instead of messaging if you are using a direct exchange, right?
I was thinking more like if I didn't want to use RPC, could I use a direct exchange to kind of substitute in?
Actually, I didn't quite understand your question.
Actually, the way that you put it, actually, that is a better way. So if the question you rephrased, can you answer that one?
yeah, I understood your question. I mean, what you were trying to say, I understood that. Yeah, okay. So what Aaron was trying to say is that the direct exchange basically directly links an exchange to a queue. So what happens is you are sending message from the sender to the receiver, but there is no complex routing issue. So what Aaron is saying that shouldn't we use RPC in that case? I mean, it would be a better option to use RPC. Is that right, Aaron? Yeah. So yeah. So why we use we can use RPC and we can use messaging as well. But there are some prerequisites required for the problem. If we are looking more for the if you're looking into more into the if you're looking for messages to be preserved, for example, to decouple the microservices more and more. Suppose A microservice has to send messages to B, but if you use RPC, what will happen is you can eliminate the message broker, and then you can achieve more speed here, as Aaron said. But the disadvantage would be that though we have removed the broker, there is no the messages are not being preserved. In messaging, what happens is we maintain a queue which will hold the messages until the receiver is ready to receive it. So if in this case, if we declare instead of declaring a direct exchange, we use RPC and the service B is down, So what will happen is all the messages passed by service A will pass through and would not be received by service B, which is currently down. So this is the advantage here. Did I answer your question?
Yeah, I think I got it. Yeah.
Okay.
Thank you.
So yeah, so the main thing is we use RPCs where we are comfortable with synchronous communication. Yeah. So if we are quite sure that both the services will be available, and we need a high throughput in the system. Although in recent years messaging has seen a lot of advancements, and very high performing messaging queues are already there, like Kafka and Amazon SQS. But yeah, still RPCs are far better than no, I won't say far, but yeah, RPCs are quite better than the messaging because there is no middleman in there. The one service is directly communicating with the other. So obviously you remove the middleman, you improve the performance. So yeah, so so there are different arguments that can be passed to if an exchange is declared to be durable. Then what happens is after if my server, the broker server, shuts down due to any reason and it gets up again, then this exchange is already there. You do not have to declare this exchange again, and this you can start publishing messages right at the very moment your broker gets up. There are some other like internal is kind of obsolete after so yeah, there are two different kind of AMQP, advanced messaging protocols, the 0.x and the 1.x. So the one we use here is 0.9.1, I guess. Yeah. So in 0.9.1, the internal is kind of depreciated and is no longer in use, and these are the other arguments. Basically, the table is a basic. It is a interface map of interface and map of. Sorry, I forgot. Okay, let's leave it for now. And yeah, so but this is where we publish to that exchange. This function basically publishes a message to the exchange, and here we send the what exchange are we publishing, and to what queue and other arguments. Yeah, this is the So this is the key. The key represents the address of the queue, that address of the tag of the queue that we are publishing to. For example, in that topic exchange, the topic in the topic if the queue is listening to a to a specific topic, then we can write the topic here. For example, if I'm writing over a topic and I would like to write to purchase, then all the queues listening to purchase topic will get this message. And then there are some other fields. Mandatory represents whether this message should go. There are multiple ways of acknowledgement, and multiple ways of sending, and multiple ways of acknowledgement and tracking. So what mandatory does it? Okay, so the multiple ways are at least one message should be received, at most one message should be received, or exactly one message should be received or sent. So what mandatory does it? Yeah. So what mandatory does it? It maintains the promise that at least one message would be sent would be published to the queues. And yeah, so the message here represents in AMQP publishing. What publishing is? It is just a simple way of passing different sort of it is way of specifying that what kind of data we are passing, and then there is this body. So in RabbitMQ we can pass different kind of content to the between two services. So we can either pass plain text, we can pass binary, and as well as some protocol buffers or load. So what we do here is, so what we are doing here is we are publishing message to exchange 1, which is a fan out type of exchange, and we are not specifying any topic or any other key, and we are publishing a message. Oh, sorry. Yeah, so we are publishing a message hello to exchange 1 and any queue listening to exchange 1, and any queue listening to listening over fan out exchange, which is basically any. So sender dot. Okay, so this has published my sender has published a message. Okay, so receiver is listening over that, and okay, so sender has published the message. If I check it, I have received it in the receiver. So right now, there is another thing that I would like to mention here is the RabbitMQ does not flush the queue. Does not flush the messages on its own. You have to send an acknowledgement. The receiver has to send an acknowledgement. Oh, sorry, I didn't go through the receiver. Oh, sorry for that. So the receiver has to explicitly send an acknowledgement for the message that yes, I have received this message, and then the sender, then the broker actually flushes the message through the buffer. So what we are doing here in the receiver.go is again we are making a connection with the broker, and then we are creating a channel, which is a virtual connection over that connection we have here, and then here we declare a queue. Now this queue that we do not have to have a name here, and then if so there are different arguments that this function takes, and almost every declare method or create method takes multiple arguments, which is very helpful in this case. So what this does is whether the queue is durable, same as just in case of exchange, and auto delete. What auto delete does is this if the receiver would not like to if the receiver queue, which is small q in this case, sorry, bad name. So if the receiver queue would not like to explicitly send acknowledgement for the messages that it is receiving, and would like to just automatically send messages to delete the to basically flush out the queue. So what it can do here is we would set the so we would set this argument as true, and then the messages we receive would send an acknowledgement on their own to the broker. So in this way we won't have to maintain a large buffer size to incorporate all the messages, and also we would also relieve from the overhead of sending acknowledgements again and again. Another there is a very important argument here is exclusive. So what exclusive does is, exclusive makes a queue bindable only to one exchange. So if there is an exchange and a queue is has been bound to that very exchange, no other queue can, no other exchange can be bound to this queue. So uh, this is done for implementing some sort of singleton kind of pattern, in which we have to just, not singleton, but in which we have to do one process exactly once, and or to share uh, one message, just to, we have to be sure that this gets passed only to one queue, or no one else is listening to this exactly. uh, so after we declare a queue, yeah, so here in this, so we have created, yeah, so overall up to here, what we have done is we have created some service A. Let's just assume we have created a service A, and then we have, what we have done in service A, we have made a connection with the RabbitMQ, and then we have created a virtual connection with the RabbitMQ, and then we have then we have created an exchange over here. Yeah, so we have declared an exchange over the in the broker, and now here we what we have done here is we have declared a queue. We have created, oh, sorry, yeah, we have created service B, in which we make a connection with the AMQP the RabbitMQ broker, and then we create a virtual connection over that, and then we have declared it. But exchange, the exchange we have declared as of now, no relation with the queue, this queue, the queue we have declared. So what we do here is we bind the queue with the exchange. Now once we bind the queue, the exchange knows that yes, there is a queue, and the queue knows that yes, there is an exchange. So there is so we introduce them to each other. Yeah, shake your hand there now. Yeah. So what queuebind method does is it takes the name of the queue, which queue has to be bound, and to which exchange, and it is listening to which topic and all. So once it is bound, we can start sending. So you can see that once this connection is complete, the exchange has been bound to the queue. So you can see that this route, this complete route, service A to exchange, exchange to queue, and queue to service B. This route is complete, and we can start sending messages from service A to service B. Yeah. So here in
I wanted to, yeah, sorry, I wanted to see
yeah.
if I have it right. So you could have one publisher or one sender, you called it, and then I could have a lot of different receivers that are all, was it called binding? They can all be binding to the same queue.
Sorry, can you please repeat?
Can you go back to the receiver.go?
Yeah, sure.
I see. So on line 31, if I have a lot of receivers that are all binding to the same queue, will they all get the same message at once?
Sorry, I didn't get your question. I'm sorry. You have to repeat again and again, but
That's okay. So let's say I have one sender and it sends that hello
yeah.
message.
Yeah, to
And
the
let's say I
receiver.
have- sorry?
Yeah, it sends hello to the receiver. Actually, it sends to the exchange, and exchange decides who it has to send to.
Okay.
The sender has, yeah. So please continue with your question.
Okay, that's good to know. Okay, so let me rephrase it then. If the sender sends it to the exchange, is there a way to make the exchange send it to all of the people, to all of the receivers?
Yeah. There's, yeah, the fan out exchange does that.
Fan out.
But,
okay. Cool.
Yeah, but again, the queue has to be uh, bound to that very exchange. There can be multiple exchanges, there can be multiple queues. A single exchange can be connected to multiple queues, and a single queue can listen to multiple exchanges as well. So
Okay.
many to many. Yeah.
Cool. Thank you.
Okay. And so, does that answer your question?
Yeah, it does. Thank you.
So now in sender.go, when we executed this function, channel.publish, then it basically the sender published to the exchange, and the exchange decided where should it send. So as the exchange is, in this case, is a fan out exchange, it will send to all the queues, which and we have just one queue, which is small queue. So it will send to the queue, small queue. Yeah, so it will send to the queue, and the queue, here we are consuming the messages. The receiver will get the message, although it is present in the queue, but the receiver will get the message only when it executes the consume function. So why is that necessary? Because it allows the receiver part, the receiver person, to go offline, and then he can consume again and again. So he doesn't have to be online. Suppose if there was an error in this line, the line 39. So, and instead of logging the error, I had panic here. So what will happen is my receiver.go will go down, and then I have to restart it. And then if I didn't have to consume, explicitly mention to consume the queue, and the queue message would okay. Oh, sorry guys, I'm currently sharing my screen. Can you see my video?
I can see your screen, and I can also see your face. It's just
Okay,
small.
okay, that's fine. Because all the time I didn't prepare any slides, and all the time I was mentioning this.
Can anybody else see? Can anyone not see both? I'm not sure if my Zoom is different or not. Okay.
So if we didn't have to explicitly mention to consume, then what would have happened is the messages would automatically get consumed right when they were published, which is obviously against the asynchronous pattern. So this obviously would have been the synchronous communication. As the sender sends the message, publishes it to the exchange, and the exchange sends it through queue, and the queue sends directly to the receiver. So if there was no receiver available, the messages would pass over like this, and the message won't get consumed. So this explicitly mentions so we are from which queue we have to from which queue we are extracting the message, and on what keys, the routing keys, and then similarly the other arguments. The auto acknowledgement sends acknowledgement here. If I turn it to true, then it will get the message would get acknowledged, and exclusive again all the yeah. Also. So here we loop over the messages we have received and just print it. So if it was, yeah. So if it were that multiple users were publishing all that queue, then thus that same receiver would have received messages from different services that we are running. So an example I would like to give here is the Uber app. So Uber is a very highly microservice. Uber uses microservices largely,
Oh no. Did he cut out? Did he cut out for other people too?
Yep.
Oh, no. Let me message him on Slack.
This is really interesting, but as with all new things, it's a kind of overwhelming when you have no previous experience with it.
Yeah. Does anybody else use these kinds of brokers?
Yeah, I have some experience with the MQTT.
MQTT. Is that software or is that just the protocol?
That's just the protocol, but there are a lot of implementations of it.
Oh,
Uh,
gotcha.
there is a Golang library called Paho by the Eclipse Foundation for it. And
Oh,
there are
cool.
open source brokers as well.
Cool. What do you use it for?
We use it for messaging in my organization. We use it to send messages from clients. So basically, we have one product which runs on some piece of hardware, and that sends messages to the cloud. So the data goes over MQTT.
Oh, God. Okay. Cool.
So it's a pub sub system.
Got it. Okay.
I believe all the broker system are basically PubSub system only, right? Most of them.
I was asking him about that. I know I've usually seen them as that PubSub concept too. But I was asking him about that because I had a discussion early last week about whether you could use these as point-to-point systems. So my idea was, or my feeling actually is you could, but it's not really a great pattern. But that's
Yeah,
just my opinion.
Yeah, it's not really. See, recently I have been involved with designing a notification system. So it was basically a design to a multi-tenant environment. So with multi-tenant environment, how do you separate masses with the notifications? It was not very large system to a scale of you say 10 lakhs or like that. It was basically a 50,000 to 60,000 messages you have to design for multi-tenant. So with if I design with point to point and listen on the each of the exchange, listening going to the queue, and supposedly I got any noisy neighbors problem, what we do in the when we separate all the tenants. So any neighbors putting too much messages, so all the other tenants will get delivery of the message will get hampered in that case. So that's why we separate it based on the each separate. So we had a discussion, either we want to have separate exchange or separate queue. So we did certain benchmark and we found that the separate queue makes more sense in the case of noisy neighbors, because if someone is trying to put too many message on the queue, we don't want to get other tenants same means delivery problem.
Yeah,
So
that makes sense. Yeah. Cool.
Yeah, I read it as yeah.
Money, we've got about 10 minutes left. I have to, unfortunately, every week I have to cut the meeting off right at 11 because I have one right after. And this Zoom software won't let me run two at a time. So we have about 10 minutes left. Do you have enough? Is it going to go over anything?
No, I can wrap it in time.
Okay, cool.
Actually,
Sorry to
sorry,
rush.
I got my very well. So I got disconnected. I'm currently using my phone as a hotspot.
Okay, thank you.
The quality won't, it won't be very good. So yeah, so the example of Uber, what we do, what hypothetically can happen is they have one service for driver allocation, one service for calculating the fare for your trip, given your starting and ending coordinates, and then there is one service which decides what route you have to follow. So so the simplest design would be user sends the request to server, it passes through the gateway and all. So the main service which handles the user request. So what that main service will do, it will first send a message to that driver allocation, sending it the my starting point of my journey, and then that service will work on it. Then the main microservice, this service is working in the background. So what this main microservice will do, it will also send similar messages to other microservices. Now this microservice will need, this is the fare calculation microservice. What this microservice needs is what route you are going to follow, and what is your starting and ending point. Because obviously the search pricing, they have to calculate search and all, depending upon the starting point of your journey. So this will need to be coupled with this microservice, the route microservice, and the main microservice. It will receive the starting point from the main microservice, route from the route detection microservice, and then we'll calculate fare on the basis of that. So now this microservice is currently allocating the driver to you. Now, depending upon what kind of customer you are, Uber basically what it does is, depending upon what kind of customer. If you are an elite customer, it will allocate you better drivers, or that was with some other operating cab aggregator. So depending upon all those variables, it will allocate you one driver. Now this microservice will allocate you the driver. This will tell you what route to use, and this will calculate the fare and just send it to, let's just assume, the main microservice. Now the main microservice will send the response back to the user app, and what will happen here is, it will send the route that you are going to use, the fare that it has calculated, and the driver which it has allocated to you. So depending on a different number of arguments that the user sent to the main microservice and then passed to the different microservices, the main microservice will react accordingly. So this is the most general case in the most general use case of messaging. So, any questions?
So do you have a general rule of thumb for how to decide between RPC and a broker? Okay.
Yeah. That's a very important question. So if you are more interested in a synchronous way of communication, you should definitely go for RPCs. There's no because obviously you would like to remove the middleman at all costs. So obviously, if the communication is synchronous, both the server and both the other two servers or two services are directly available and are willing to contact with each other. The willingness to contact is more important, actually. So if both are available and are willing to contact with each other and are visible to each other, then you should definitely go for RPCs. But if we have one of the service might not be available, or you need some complex routing scenarios, or you do not know where this service is currently hosted, as might be in case in some of the services. So if you do not know all these things, then you can use RP. If you do not know all these things, then you should use messaging. And also apart from this, though you can implement the features of messaging in RPC and some of the features of RPC using RabbitMQ, because it also supports RPCs. So you can do that as well. But what I will recommend is just stick to what is the best solution at the current moment. So synchronous, go for RPC. Asynchronous, go for RabbitMQ. And complex routing scenarios, go for RabbitMQ. Simple routing scenarios, go for RPC. And then, for example, if you have to fan out to multiple services. For example, in this case, I had to send the starting point to the driver allocation microservice, to route detection microservice, and the fare calculation microservice as well. So in this case, it would have been a better, better option to go with messaging. Though a lot of different arguments can pose to that. Yeah.
Awesome. Would you say use a cloud broker or use RabbitMQ?
Sorry?
Would you say to use a cloud broker first or RabbitMQ first?
Yeah, so that is a debatable thing. If you are using, if you would like to go with something like Amazon SQS, so that is quite easy to set up and all that. You don't the learning curve is quite low. You can easily learn that. And then there is RabbitMQ. RabbitMQ has very powerful routing techniques. So whatever you can imagine, whatever the receiver can be, you can send your message to any receiver. Basically, it can be anything. Yeah. So any complex routing scenario you can think of, you can implement it in RabbitMQ. So it is that powerful. But the performance is not so good. It is good, but not so good. For example, Kafka is Apache Kafka is somewhat better than RabbitMQ, and Amazon SQS is an equal of that. I read an article which had some benchmarks. So I haven't tried both of them on my own, but definitely Kafka is better than RabbitMQ.
Cool.
But if you are thinking of complex routing scenarios, then RabbitMQ is slightly better. Kafka has publish and subscribe. And sorry, I forgot to answer one of your questions. Can you remind me of?
I think you answered all of mine. Who else has questions? I've been asking all the questions. I know somebody else, at least one other person has questions. Anybody? Everybody else is so much smarter than me, huh? Okay.
I think it's more like you don't dare. Yeah. So you should have credit for daring to ask.
You know, I hope that this is laid back enough. Anyone can ask. Everyone feels comfortable.
Yeah, but as I said earlier, at least for me, this is a great way to get an introduction to how this works, and I really need a couple of days to dig deeper into this. Then maybe in a week or so, then I will have some questions. But now it's yeah.
Oh, Michael DeBarros asks, can you give a link to your code?
Okay. Yeah, I can publish that. So yeah, I can publish it to basically you can get all this code from RabbitMQ website. But the thing is, I won't recommend directly going to that website, because the very first example they have given is that you can directly publish. What they have given is you can publish to a queue. Though what happens is it gets passed through the direct queue, that which they explain in the second example. So I got confused when I went through the documentation. So just keep in mind, the message always is published to the exchange and is always consumed through the queue. Yeah. So that's.
Do you think that code is a good place to start, Money?
To update that code.
Oh no, do you think it's just a good place to start and then to learn about that problem and so forth?
Yeah. So the RabbitMQ website is great. You can basically read all the examples and all how the architecture and all everything that I mentioned through that website. Yeah. So that is a very nice place to start. But I would recommend some other courses, online courses, video courses. I learned through RabbitMQ website, the documentation, and the Pluralsight courses, 1 or 2. So the RabbitMQ is definitely website is definitely a great place to start.
So I see that there are 3 Go tutorials. I see one. I'm just going to paste them all in the chat here. 1, 2, and 3. I'll paste these up into the study group Slack channel too.
Thank you. I can provide some links on the Slack channel regarding the benchmarks and all.
All right. Okay. Sorry again about my Zoom issues. I have to close down the meeting now. I swear I'm figuring this out, but Zoom is not being very cooperative. So sometime soon this will be solved. Anyways, thank you everybody for coming.
Goodbye.
And we will see you next week. And thank you again, Money. This was awesome.
Thanks a lot, Money.
Thank you.
Bye, everybody.
Goodbye.
Bye.